Good day. Welcome to our Filter Systems Rental Program webinar, where we're going to review the products that are in our Hydac Rental Program product offering, as well as the details on how to rent a unit. Okay, so starting off, one of the things we want to cover is what fluids can we filter with our products? Well, it's a very commonly asked question, and the answer is actually quite simple. We can filter, dehydrate, and/or provide condition monitoring data on most commonly used hydraulic fluids in industrial MRO and OEM applications. So for filter carts and filtration skids, so these would be anything we would use for a common hydraulic oil in a plant. They're compatible with mineral oil-based hydraulic fluids. We can filter water glycols, synthetic fluids such as your Cosmolubric or your Quintalubric, phosphate esters, commonly used fire coil and Skydrol, as well as transformer oils. For dehydration units, both our positive pressure and vacuum type style, these are going to be compatible with any of your mineral oil-based hydraulic fluids, your synthetic fluids, phosphate esters, particularly just fire coil, and transformer oils. Note we've removed water glycols from dehydration units because you do need water in the water glycol fluid so it will function correctly. Contamination sensors, we can count ISO count data on any of our mineral oil-based hydraulic fluids, our synthetic fluids, phosphate esters, including fire coil and Skydrol, as well as transformer oils. If you don't see your fluid noted in the list above, just ask a member of the Filter Systems team if we can filter it, and we'll be happy to let you know. So our equipment rental program for in-plant fluid cleanliness is a newer program for Hydac. Based on our experience, we know that a strategically placed oil dehydrator can make all the difference in a plant or factory, removing any of that inborn water that may be coming into the hydraulic reservoir. By having state-of-the-art technology available for our customer, we're able to solve even the peskiest problems of contamination in your plant. So we can put your mind at ease, knowing that today's not the day that surprises you with hours of unplanned downtime. By offering our rental program, we can extend proven fluid conditioning technology to a wider reach of customers. Available for rent are some of our larger fluid conditioning systems, such as our offline fluid conditioning skids, our polishing skids, mass transfer and vacuum dehydration, as well as varnish removal systems. So the first product we're going to cover is our MAFHE series of dehydration stations. So these are going to be our mass transfer dewatering units to remove free and dissolved water from your oil. These units do include a heater option, so we can warm the fluid up for better water removal. They are easy to operate with simple touchscreen controls on a user-friendly HMI. We can achieve water contents of less than 50 parts per million. We have 2 units in our rental program, a 15 gallon a minute fixed flow rate, as well as a 22 gallon a minute fixed flow rate unit. All of our dehydration units in our rental program are 460 volt, 60 hertz 3-phase units. They're available for use in anywhere from a 500 to a 4,000 gallon reservoir, so we can encompass majority of the hydraulic reservoirs seen in industrial or OEM facilities. So what is the mass transfer process? So this illustration just shows how the fluid is coming in through an intake pump. The fluid is going to go through a heater. It's going to be warmed. The fluid is then sprayed into the reaction chamber shown in the middle of the illustration. The reaction chamber is actually filled with a type of media that allows the fluid to become thinner and more evenly dispersed throughout the chamber. What that does is it aids in better water removal. Next to the chamber, you'll see a blower. So we are actually taking the ambient air in the plant. We are conditioning it through a patented process and introducing it into the lower half of the reaction chamber. As that warm conditioned air travels up into the reaction chamber, it's going to be met with the wet oil that is being showered down into the media. As the air and the oil meet, that water will transfer from the oil into the air and then being expelled out through the breather at the top of the chamber. So what you are going to have is you're going to have water being returned back to the atmosphere. It does not add humidity to the environment surrounding it. So you no longer have that wastewater to dispose of that you see with a traditional vacuum dehydrator. The dry oil is collected in the bottom of the chamber. It is then pumped out through a particulate filter and then returned back to reservoir. The only maintenance you have with these units is replacing a particle filter element as well as your breathers. There is no expensive vacuum pump to maintain. So it's leaning more towards that green solution. So we're going to be saving energy in our process, as well as reducing the amount of contaminant that we then have to pay somebody to dispose of. So peppered throughout this presentation, you will see some success stories where we've rented and or sold our product into various industries. So our success story with our MAFHE was in a paper mill. We had a very paper mill that had a very large reservoir, about 2,500 gallons of an ISO 220 oil. They had a constant water ingression oil. They were seeing large water events weekly, resulting in free water in their system. We know the free water was causing premature wear to the pumps and valves. They did have a competitor's 20-gallon vacuum dehydrator installed in the system, but they wanted something that would require minimal user intervention. They wanted to be able to plug it, play it, walk away, and not have to go back unless it required maintenance. So the existing vacuum dehydrator was able to maintain a saturation level between 60 and 75%. But when they did have a high water incident, they did have to go over and adjust vacuum levels to account for those high water ingression rates. The maintenance on this vacuum dehydrator was very expensive as well, over $15,000 a year for the vacuum pump plus incidentals. We delivered and installed a 15-gallon a minute MAFHE. It was installed on the reservoir. As you can see, the pictures are next to the hydraulic reservoir in the plant. The user only had to enter the heater temperature setting and his target saturation level. This unit was able to maintain the saturation level that the customer wanted of 50 to 55%. Maintenance requirements were reduced to $2,000 annually. This MAFHE has been operating on this site 24/7 for well over 3 years with minimal service requirement. These units also have an auto restart function. So when the target saturation level is met, the customer unit will shut down periodically with the auto restart function. It will turn itself back on. It will look to see where the saturation level is. If it exceeds your saturation target point you've set, the unit will then run until that saturation level is again met and shut down. So again, leading to the energy saving feature. Now our MAFHE dehydration station is our smaller unit compared to the MAFHE, the same technology, removing free and dissolved water. However, there is no heater supplied on this unit. It is very simple controls, as you can see from the control panel, just an on-off switch. We can achieve that 50 parts per million water content, but the flow rate here is approximately 1.5 gallons a minute, and it uses standard 115 volt 60 hertz single phase power. This unit is designed for very small reservoirs, 10 to 500 gallon reservoirs. But the caveat with this is that oil needs to be greater than 110 degrees Fahrenheit for optimal water removal. And it is for fluids less than 1,000 SUS. So we did use our MAFHE in plant for fluid conditioning. The application was a customer that produces faucets for kitchens or bathrooms. They use a polyalpha olefin fluid in their processing. The parts are then water washed, and all of that water then combines with that PAO fluid in the 350-gallon reservoir that they collect all of that fluid into. Periodically, they would send out those totes of oil to the oil vendor. The oil vendor would then reclaim them and send them back for reuse. It's a very expensive proposition that would have to happen quite frequently. We installed an MAFHE dehydration station to reclaim the PAO fluid. The starting water saturation was 77%. After cycling the tote of oil through the MAFHA, we were able to get down to 30% saturation after 72 hours. This fluid could then be reintroduced into the lube system. An estimated cost savings was about $20 a gallon of fluid per 350 gallons in each tote, was $7,000. They were able, just by cleaning up 2 of the totes of oil, to recoup the expense of buying the dehydration unit for in-plant reclamation. Now our NAV30 vacuum dehydrator, this is our North American vacuum dehydrator. This is a newer product for Hydac where we have taken vacuum technology using USA components. The vacuum dehydrator will remove free dissolved water as well as dissolved gases that are in the oil. It does include a heater option. Like our MAFHE units, it does have simple touchscreen controls with minimal user intervention in order to get the unit to run. We can get water contents down to 10 parts per million, and that's due to the vacuum technology incorporated into the equipment. This unit is a 30 gallon a minute flow rate, 460 volt, 60 hertz, 3-phase power supply. Ideally, you want to use this on a 2,000 to 7,500 gallon reservoir due to the high flow rate. The process here, as represented by the blue arrows, is the oil flowing through the equipment. It's coming in, going through a heater, going into the reaction chamber, and then it will go through the filter and then back to tank. Much like the mass transfer product, the airflow is coming through the chamber. The air in water is coming out of the top of the reaction chamber. It will be condensed using one of our coolers. That condensed water will then go through a coalescing filter, and then the liquid water will then be trapped in the sump located near the bottom of the dehydration unit. That water is then collected and will have to be disposed of in accordance with your local requirements. Now, an application success for our NAV30 was in a local steel mill. So the steel mill had a very high water content in their main lube system. It was a 7,500 gallon reservoir of an ISO 320 gear oil. There were no water-cooled heat exchangers on the system. The customer needed to drop the water content to less than 1,300 parts per million in order to maintain proper lubrication to their gearboxes. While we were there with the rental unit, they also asked us to help them locate the source of the water ingression. We installed the NAV30 on the customer system. The oil reservoir was approximately 115 degrees Fahrenheit. We installed it within 10 feet of the reservoir. We took some bottle samples once the unit was up and operating and the oil was circulating through the unit. The initial Carl Fisher water readings were approximately 26,000 parts per million. And in this system, that equated to approximately 200 gallons of free water. They were not able to drain that free water off the bottom of the tank. So during the first few days, we noticed we could only remove about 30 to 40 gallons of water per day. Our heater on our unit was just not able to heat that 7,500 gallon reservoir up to the temperature for optimal water removal. The customer did not have heaters in the reservoir, so what we did was we ran spare pumps in relief. We got the tank heated up to 145 degrees. The water removal increased to 55 to 60 gallons per day. So as you can imagine, the water was just pouring out of the sump. Once the water content was down to about 10,000 parts per million, we started taking samples throughout their plant before and after the gearboxes to help them locate the source of ingression. We found higher water concentrations after the main gearbox and suggested they change all the seals to prevent the water contamination from entering the reservoir during their daily washdowns. We also noticed high water in the return lines while they were in shutdown mode. This plant had about 5,000 feet of piping running throughout the system, and during mill shutdown, the pipes would condensate as the oil was cooling down in those lines. So we recommended that they flow oil through the system on shutdowns to reduce condensation in their piping systems. After 30 days in operation, the NAV30 had their system down to 300 parts per million water content, and we were able to manage the daily ingression from washdown and condensation. So if we're not trying to remove water from the oil, what we want to do is we need to remove the particulate contamination from the customer's oil, because we know that particulate contamination can be just as dangerous to a customer's system as the water can. So one of our units that we have for particulate contamination is our OFSA filtration station. So this is our filter cart with an onboard particle counter and water saturation sensor to display both the ISO and water saturation levels of the hydraulic oil. It is going to be two 18-inch filter elements in series or stage filtration, having a 10 and 5 micron element installed in the filter housings. It is very simple controls where it's just an on and off. The particle counter can be programmed to your target saturation, so you're running in auto mode that the unit will shut down when that target ISO code level is met. This is a variable flow unit of 3 to 8 gallons a minute with your 115 volt 60 hertz single phase power supply. It's ideally recommended for small reservoirs, 10 to 500 gallons, just due to the flow rate of the unit. And it is for hydraulic mineral oils less than 1,000 SUS. So some features of this unit would be the real-time monitoring of ISO cleanliness classes. So the user will know that the oil in his hydraulic reservoir is clean. The automatic shutdown mode, when the user-defined ISO codes are reached, is very important because they could set the filter cart up at the end of the day, had their programmed ISO code in there. When that target ISO code is met, it will shut down. So when they come back in the morning, that they know that their reservoir will have clean oil ready for use for the day. There's an integrated USB port so they can download the ISO code data to a computer if they need that information for further processing or to print it. With the water saturation sensor on there, we have real-time humidity data that is displayed right on the control panel. One of the nice things with this cart is there is a bypass valve on the rear of the cart. So we have filtered the hydraulic reservoir. They can move the bypass valve into transfer mode and then use the same cart to transfer the oil from that hydraulic reservoir into whatever piece of equipment that hydraulic fluid needs to be in. Now we have combined units for dual application in a plant. This happened to be a combination of our filtration station and our MFHE dehydration station at a wind farm. So the problem here is the customer had an ISO 32 ISO certified oil that they would use in the wind tower rotor. So the rotor is the hub that has the 3 blades attached. This oil had been significantly compromised with water contamination. They were not able to get certified replacement fluid to the site for up to about a month. So the customer needed a quick solution to remove the water from the oil on site rather than disassemble each tower rotor and then send those to the shop for cleanup. So our solution was to offer the customer our MAFHE to remove the water and then the filtration station to show that the water level and the particulate ISO count were where they needed to be. So all of the wet oil was collected into totes. And as you can see, the units were mounted onto a trailer with the tote for processing so they could drive it from wind tower to wind tower. So each tote had a water saturation of greater than 100%, so about 4,400 parts per million, with visible free water in each tote of oil. Within an hour and a half of running the dehydrator, we had the water saturation level down to 18%, so about 80 parts per million, which took us back to virgin level water content. The total water removed was about 3.5 liters. We were able to clean up 3 rotors in 3 days on that system. The filtration station was used to show that the ISO level and the water saturation was within the acceptable levels for their ISO certified oil, and it created a permanent record of the achieved cleanliness. Overall, the customer told us that we were able to save them $1 million. That $1 million included the cost of the downtime, the labor savings of 25 people on site, the charges for the 3 cranes that were on site to lift that rotor up onto the wind tower nacelle, and the transit time from the site to the shop and back. So just by a small rental opportunity was a very large cost savings for the customer. Now for customers that have a very large reservoir permanently installed in their system, we can use our OFX skid offline filtration system. So this is going to be a stationary offline filtration unit with an included motor starter and our Hydac high viscosity condition monitoring system that includes both the CS1220 and an aqua sensor for water saturation, as well as our CSI C11 contamination sensor interface for data acquisition and retrieval. Our X-skid is a fixed flow rate of 37 gallons per minute with our 460 volt, 60 hertz, 3-phase power requirement. It is designed for oils up to 5,000 SUS and hydraulic reservoirs up to 4,000 gallons. So applications for the X-skid can be used on any filtration system for filtering critical component reservoirs, bulk storage tanks, and transferring of fluid from delivery to point of use. We do offer these as customizable filtration units, so we can protect and extend the life of expensive components and minimize downtime and maintenance costs. The optional onboard condition monitoring, we do have that as standard on our rental skid, is used for trending to provide the information and data needed to perform predictive maintenance to help the end user greatly reduce those breakdowns in the field due to contaminated fluid. Our VMU4 is our varnish mitigation unit. This unit is reused to remove free and dissolved varnish via absorption elements. The VMU4 has 4 absorption elements, as well as pre and post filtration. This would be used to catch any particulate contamination before it enters the absorption elements. With this unit, the pre and post filter will be included. However, the absorption elements are not supplied and they're purchased as a separate line item. This unit has a simple motor starter to, turn the unit off and on. Again, it is going to be a 460 volt, 60 hertz, 3-phase power supply. The flow rate on this unit is only 2.4 gallons per minute because when we do want to remove varnish from the oil, we do need to do that as a very slow process, so we make sure we capture all of the varnish precursors. This unit is for mineral-based fluids under 370 SUS and up to 4,000 gallon reservoirs. So, you may ask, what is varnish? Well, varnish is the type of clear coating that can plate out on a cool metal surface. It can be a gel, a resin-like, or a solid deposit that form in a system. So some examples of varnish that you may have seen in the field could be varnish on the housing cover of the hydraulic pump. You see the sludgy residue on the top of a filter element. You can see varnish on the tank wall, so that is that dark discoloration at the fluid level. So the cause of varnish deposits is oil aging. So by incorporating a varnish mitigation unit, you can actually remove those varnish precursors from forming and prematurely aging that oil. Quite a few applications for our varnish mitigation units are going to be in a power generation. This example is in a steam turbine. So this was a coal power plant with a steam turbine showing an MPC value of 40. The MPC value is our membrane patch color imagery test, which is the test we use to determine if a system actually has varnish in it or not. That 40 translates to the color of the residue that is present on the filter patch. So the customer was seeing deposits of oil aging products on the components and on the tank walls. They were seeing their oil actually become cloudy, and they were having it rapidly age. They were having problems with valves failing because those oil aging components or that varnish was actually impeding the function of the valve. So the customer's MPC value of 40 indicates increased varnish formation in the turbine. This caused deposits to form in the system. So they saw the valve malfunctions. They saw reduced working life of the valves, the pumps, and the oil itself. They saw heat transfer reduced because that varnish was coating, those varnish precursors were coating on the cooler, that cool surface. And they received clogging of the filter elements. So by incorporating a VMU4, it made it possible for the customer to reduce the varnish very efficiently in his system. They were able to see increased plant reliability and reduce that unplanned downtime. Now, as the graph illustrates, this does not happen overnight. This is a very slow process of removing the varnish precursors from the oil, and it may take several months to get the system where all of the varnish is removed. Again, though, you can see great savings per year just by incorporating a varnish mitigation unit. So how does the rental program work? So the first thing we will do is we need to review the application with a member of the filter systems team to define the equipment needed for the application. We need to know some basic fundamentals about the system. What is the oil type, the reservoir size, and the fluid temperature the system is currently running at? What is the pumping distance, both horizontal and vertical? And what power is available where the unit will be used? As I mentioned, most of our products are going to be 460 volt three-phase units. If we don't have that power available at that location, we will perhaps need to go another way with a unit. We will then determine the availability of the appropriate equipment. The filter systems team will send the equipment rental agreement to you for review. You will then sign the rental agreement and return that to us with a purchase order for the amount of the first month's rental. All of our equipment is designed and manufactured in the US. As part of the rental agreement, the end user is responsible for freight costs to and from Leedsdale, Pennsylvania. Our dehydrators and filter carts will come with connection hoses and power cables. The hoses and power cables will need to be returned to us in the heavy-duty shipping crate that the units ship in. New filter elements and breathers will be installed upon shipment for most of our equipment, and it is highly recommended that customers purchase spare elements and or breathers at the time of rental so they have them available for use throughout the rental period. Our preferred rental period is 1 month. Our filtration station filter cart can be rented for 2 weeks at a time if necessary. All equipment will be shipped in this heavy-duty crate. The end user must use the same crate to return the equipment, including the connection hoses and power cables, to Leedsdale. The units will be inspected upon return for any damage, and part of the signed rental agreement is the customer is responsible for any damage incurred to the unit while it is in their possession. And lastly, we would just like to do a reminder that we do have a quick delivery program. So we have the majority of our rental products in our quick delivery program. So if the customer decides to purchase rather than rent, we have quite a few of these product offerings sitting on the shelf ready for shipment. So the customer can easily increase their sales dollars with clean, dry oil. Customers will see improved reliability because we know there is a cost to the customer for catastrophic failure. Most importantly, the Filter Systems team is here to help you. So call or email us with any questions that you may have. And with that, I thank you for your time and attention today.
Thank you, Christine. It was very informative.
Sure.
I'm going to stop.
You speak really well, Chris.